All right, guys, today we're looking at a quick little rundown of root numbers and how we can solve some of those. So again, if we're taking the square root or cubed root of something, we may end up with a whole number or we may end up with an irrational number. So let's take a look at these. So let's first look at some of these irrational numbers. So if we have the square root of a number that is not a perfect square, again, perfect squares are like 1, because 1 squared equals 1, 4, 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, 5 squared equals 25, 6 squared, 7, 8, 9, and continuing on. If we took the square root of these, we would end up with a whole number. But numbers like square root of 3, square root of 5, okay, those are going to give us numbers between our whole numbers. This would be between 1 and 2, this would be between 2 and 3, but they're going to be irrational numbers. So that means a decimal like pi goes on forever. So we want to express them like this instead of as a decimal number. Unless we're told to express them as a rounded decimal number, we want to leave them in root form. So again, we can look at a number and use what we know about our perfect squares to determine where about this number is. We can obviously punch this into the calculator and hit enter and get a big long decimal also and tell us what whole numbers it's between. But the square root of 78, well, I know the square root of 81 is 9. Square root of 64 is 8. So the square root of 78 has to be somewhere between 8 and 9. It's going to be closer to 9 than it is to 8. But that tells me where it's going to land between. So again, it's still going to be irrational because this is not a perfect square. These are, so that's why they work out to be whole numbers. Okay, but we can use that information to help us figure out where it is. And you will see some multiple choice questions on the test asking that. So again, you can put it into your calculator, hit enter. If it's, the square root of 78 is 8.83176,086. So I know it's closer to 9 than it is to 8, but it's between 8 and 9. So you can do it that way, okay? Or you can know what you remember about perfect squares to determine, well, it's not greater than the square root of 81. It's not less than the square root of 64. So it has to be between these two whole numbers. Another property we have that we need to apply, and this is on your reference sheet, properties of square roots. If I have a times b, I can break that apart under the square root sign. I can break it apart to the square root of a times the square root of b. Now, if we're adding in there, this rule doesn't apply. It's for multiplication. So what we mean by that, let's take a look at the square root of 36. I know the square root of 36 is 6 because 36 is a perfect square. Okay? But I can break it apart. I know 9 times 4 equals 36. So the square root of 9 times the square root of 4 should work out to be the same thing. So let's take a look. The square root of 9 is 3. Square root of 4 is 2. 3 times 2 is also 6. So that's all we're using right here. Now we'd probably just do square root of 36 equals 6. We probably wouldn't break it apart like this just to create more work. But there are times where we're going to need to pull out a perfect square of these numbers in order to simplify it. So if we see a test question like this, the square root of 200, we're not just going to punch in square root of 200, which is 14.14213562. If you do that, you're getting it all incorrect because that's not what this is asking. We want to think about, are there any perfect squares that go into 200? 4 goes into it. Is there any larger? 100 goes into it. 100 times 2 equals 200. So I know I can break this apart to the square root of 100 times the square root of 2. Square root of 100 is 10. So I can express this number of 10 root 2. Now another helpful hint, way to use your calculator. You can't use your calculator to get this. Some old calculators, I think, were able to express in root form, these TI-84s, if there's a way. I don't know how to do it. But we can use our calculator. Go in and hit the square root of 200 and hit enter. And then go to 10 times the square root of 2 and hit enter. And they're going to be the exact same decimal numbers. If they're not, then you know you did something wrong and you need to check your work. So yeah, we get 10 times the square root of 2, and it's 14.14213562. Not just close, the exact same. So this is equal to that. And we leave it like that because it's irrational, but we have it simplified because we've pulled out a perfect square. Now let's say we have 48. Okay, well, 9 doesn't go into 48. 25 doesn't, 36 doesn't, 16. 16 goes in. So 16 goes into 48 3 times. So we're going to break this apart using that property of square root of AB equals the square root of A times the square root of B. Now the square root of 16 is 4, square root of 3 is irrational, and I can't pull out any more. If I could, if there was numbers I could keep pulling out of there, I would continue to do that, but that's as far as I can go. And again, punch this in and this, they're going to be the exact same checking word. So we'll do a little bit more with that down the road. That's just a quick introduction to root numbers. They're irrational, so we want to keep them in root form, but if we can pull out a perfect square out of them in order to simplify them, then we want to do that as well.